We're going to look at section 1-1, which is translating algebra into English words and vice versa, English words into algebra. So you do have some vocabulary that you have to be aware of. So the first piece of vocabulary is a constant versus what's a variable. So if we look at the following, 2x minus 5. So that's known as an algebraic expression. And within this expression, we have both a constant and a variable. So there are two terms here. This is one term, and this is the second term. This term right here, the 2x, is called your variable term because it has a variable in an x. The minus 5 is your constant. So the definition of constant says a value that does not change. -5 or -5, it's not going to change. There's nothing in this expression that's going to change the fact that that's a -5. However, a variable is a letter or a symbol that can represent a value that can change. Because of the x here, the value of this term 2x changes depending upon what x is. So if I let x be 2, the value of this is 2 times 2, 4. If I let x be -3, the value of this is 2 times -3, or -6. So depending upon what x is, will depend upon what the value of that variable term is. So a variable term just means that it has a letter or a symbol in there that changes the value of that term, whereas a constant is just a number. So an example of a constant could be what we have up there, the -5. That's a terrible -5. It could also be 0. It could be a positive number. It can be a fraction. It could be a decimal. It's any number that you can think of. Whereas a variable, it could be any letter of the alphabet. X is a very popular one in algebra, but it could be the letter A, it could be the letter L, it could be the letter Z, any letter from A to Z in the alphabet, or any symbol. A lot of Greek symbols are used in mathematics. A numerical expression is what we were doing last week with integer rules. So for instance, if you had a -5 minus a 2, a numerical expression may contain only constants or operations. So here you've got constant numbers, a 2 and a -5, and it's got this operation symbol of a minus. It could also be just one number, or it could be a number raised to an exponent. So long as there's no variables in there, it can just contain numbers and operation symbols. Versus the algebraic expression, this is an algebraic expression right here. It says it may contain variables, but it doesn't have to, constants and or operations. So this that we were working with earlier, this 2x minus 5, matches that definition of an algebraic expression. So it's got both constants and variables in there, but also it doesn't have to, an algebraic expression does not have to have a letter in it. It could be what's up above. It could be -5 minus 2. Again, it could be just a number. It doesn't have to have a variable in it. It could be a square root of, I don't know, y squared. So all numerical expressions are considered algebraic expressions, but not all of these algebraic expressions are numerical expressions. For instance, 2x minus 5 is not numerical, it's just algebraic. Whereas this is both numerical and algebraic. This is both numerical and algebraic. This is just algebraic. So the ones that have letters in them or symbols, those are just algebraic. And the ones that have just numbers are numerical and algebraic. And then the last little bit we have here is evaluate, and it just means to find the value. So that's what we were doing up here earlier when we were evaluating 2x given that x was 2 or negative 3. We were finding the value. And so you just need to know those directions. So before we get to looking at how to write the algebraic expressions in words, let's go ahead and look at some words that we can use in place of addition, subtraction, multiplication, and division. So I'm going to erase a few things up here. Maybe. If it'll let me. It's not going to let me. That's awesome. All right, so instead, I'm going to go ahead and make this just a little bit bigger over here. And then I'm going to put a box, actually 4 boxes, and here I'm going to put an addition symbol, subtraction, multiplication, and division. And there's lots of words that we can use in place of a plus sign. So if we were looking at the expression 2 plus 3, so instead of the addition sign, we could use plus. We could use 2 more than 3, so we could use the expression more than to mean addition. We can use 2 increased by 3, so we can use increased by. One of my favorites in a higher level of words would be the sum of 2 and 3. And we'll talk about how we use the sum of. So you're going to circle that because it's a high level word. As you come across more words that we use for addition, you can put them in here to kind of collect them and help study. There's several ones that we could use. So let's move on to subtraction. So for subtraction, the most basic one would be minus. So if I had 5 minus 2, we could use minus in place of subtraction. Also there's less than. You have to be careful with less than, because less than has to be written a specific way. So I'm going to put just a little star right here, and I'm going to kind of circle it with purple, because that one's important. We'll talk about that one in a minute. Then decreased by, so 5 decreased by 2 could also mean subtraction. And then branching off of sum of, we could use difference of. So circle that one. I'm going to circle it in green. And we'll talk about how to write that one also in a minute. So these are just some examples. They're not the end all be all by any means. There could be other ones that you could use, so make sure if you're not sure that you come ask me. Then for multiplication, clearly our basic word for our base word for multiplication would be times. So you can replace 2 times 3. You can replace the multiplication symbol with that word times. You could also use the product of. So that goes along with sum of, difference of. So we're going to use product of. You could do 2 multiplied by 3. So multiplied by. And there's some other kind of special words that we use for multiplication, but it specifically means that you're multiplying by a particular number. So for instance, if you use the word double, you could say double 2, and that just means that you multiply 2 by 2. Or double 10, you multiply 10 by 2. Well, that brings us into that you could use tripled. That means you multiply by 3. Quadrupled, multiply by 4. You've also got other ones where you're squaring or cubing, and those are just different forms of multiplication. So bear that in mind, that those could be possibilities. And then for division, clearly if we had, and I'm going to show you here, if we looked at this fraction and you were to read that, technically you would want to say that it is, let me choose a good color. So you would say 3 divided by 5. A lot of you want to say 3 over 5, and I catch myself saying that a lot too, but you're not allowed to say that, so you're going to cross that one out, that you can't use 3 over 5 because that's not an appropriate translation for division. There's not a whole lot for division, so divided by, along the lines of sum of, difference of, product of, we would have quotient of. And again, I'm going to talk about how to use those 4 phrases in just a minute. So those are just a few that we're going to use down here below. Get that smaller. There we go. All right, so given what we just went over, you're going to give 2 ways to write each algebraic expression in words. So we're going to do one that's kind of a low level and one that's a higher level using the sum of, the difference of, the product of, and the quotient of, and so forth. So the first one that we have is x plus 3. So instead of x, you're going to, anytime you have a variable, you're going to say, instead of x, you'll say the number x. And then instead of addition, you heard me say plus. So you could say plus, you could have used more than, any of the lower level words up there that you can do. So the number x plus 3. So you want to write out the number 3 because we are converting from math into words. So there's one way, the number x plus 3. If we're going to use the expression sum of, anytime you use any of those expressions, sum of, difference of, product of, quotient of, it always has to come first. So if we're going to use the sum of, we're going to put the sum of, and anytime you use this phrase, 100% of the time it has to be accompanied by the word and. So you're going to be adding sum of, you're going to be adding 2 things together. What are the 2 things you're adding together? The number x and 3. So the number of x goes here and 3 goes here in the same order that they gave you. So the sum of a number, I'm running out of room here, x and 3. So there's just 2 ways for addition. And then look at example 2 for subtraction. You have to be careful with subtraction and division. It makes a difference in what order you subtract and divide in. So a low level for example 2 would be 4. And instead of the subtraction sign, a low level would be minus. So 4 minus a number n. So that's a low level one. We're going to actually do 3 for this one because I want to talk about the less than. So we started the less than, and I want you to understand that any time that we use less than, you're going to have to flip-flop these 2 amounts. So if I'm going to use the phrase less than to represent subtraction, we're not going to say 4 less than n. It has to go in the reverse. We have to have the number n first and then 4. So the number n less than 4. So make sure that you study this one. I'm going to star this because it matches what we did earlier. And then now we're going to look at how do we use the difference of. So if we're going to use the difference of, remember that phrase always comes first. So the difference of and 100% of the time it's accompanied by the word and. What two things are you subtracting? And you want to go in the exact order that they gave you. So we're subtracting 4 and a number n. So 4 comes first. So we've got the difference of 4 and a number n. So we did 3 for example 2. Then for example 3, remember we cannot do a number t over 5. You're not allowed to use the word over. So low level words would be a number t divided by five. If we're going to use that phrase quotient of, remember that phrase always comes first. So the quotient of and 100% of the time it's accompanied by the word and. And so what are the two things we're dividing? The number t. Again, I'm running out of room, so the number t and 5. So that's really it as far as converting from addition or from algebra into English words. It's more of a matter of you have to practice and ask questions and just get out there and do it. So let's look at the next page. So on this one we're going to translate from words into an algebraic expression. So let's look at the important parts of this. So read the whole thing through. Eve reads 25 pages per hour. Write an expression for the number of pages she reads in H hours. So the fact that she reads 25 pages per hour is important. That's a rate. 25 pages equals 1 hour of reading. So to kind of figure out what your expression is and whether we're using addition, subtraction, multiplication, or division, it might be helpful to put a table together. So this is going to be my hours, number hours, and this is going to be pages. So we're going to have 1 hour, 2 hours, 3 hours, and 4 hours. So after 1 hour, according to this, Eve should have read 25 pages. After 2 hours, she should have read 25 pages plus 25 pages, so that would be 50 pages. After 3 hours, Eve should have read 25 plus 25 plus 25, 25 pages per each of those 3 hours, or couldn't we just do 3 times 25? So that gives us 75. And after 4 hours, it's 4 hours times 25 per hour, so that would be 100 pages after 4 hours. Then, because my hours is the part that keeps changing, it's the unknown part, that if I knew my number of hours, and furthermore they told you that they wanted it in terms of H hours, then I want to know what am I going to do to H to get my number of pages. So I kept choosing values for H here. And what do you do to 1 to get 25? What do you do to the hours of 2 to get 50? What do you do to 3 to get 75? What do you do to 4 to get 100? So to go from 1 to 25, I could either add 24, or I could take 1 times 25 is 25. To go from 2 to 50, I could either add 48, or I could do 2 times 25 is 50. To go from 3 to 75, I could add 72, or I could do 3 times 25 gives me 75. Do you see a common pattern here? If I multiply each one of these by 25, I get these answers. So that's the common theme that's going through here. So does that work for 4 hours? Is 4 times 25 100? Yes. So whatever my H is, if I multiply H by 25, then I'm going to get the value that I want. So my answer, my expression, is going to be 25 times h. Then look at example 2. Lou drives at 65 miles per hour. That's another rate, just like reading 25 pages per hour above. Write an expression for the number of hours that Lou drives in t hours. So again, if you look at a table of values, kind of think your way through this. If I let h be hours, and then so you might have noticed that there's an error here. We cannot write an expression for the number of hours that Lou drives in t hours. This should be write an expression for the number of miles that Lou drives in t hours. And so this should be miles here. And I'll tell you why I know that. Watch what happens in our table here. So after 1 hour, Lou will have driven 65 miles in that 1 hour because he drives 65 miles per each hour. So after 2 hours, I would have 2 of these 65s. So 2 times 65 is 130. After 3 hours, when I do what we did above, I'm going to take 3 times 65 because I've got 65 plus 65 plus 65. So 3 times 5 is 15. Carry the 1. 3 times 6 is 30, plus the 1 we carried would be 31, and so forth. So if I want to know what Lou drove in t hours, because they're letting the number of hours be t, not h, then every time from here to here to here, I did 1 times 65. 2 times 65 is 130. 3 times 65 is 315. So here, I want to take t times 65. So it should be 65t. So my answer is 65t. That means that my answer is in terms of t hours. Let's look at the last couple of problems here. So this time we're going to evaluate algebraic expressions, and you've been given some values here where x is 8, y is 5, and z is 4. So anytime you come across any one of those variables, you're going to replace them with these values. So in expression 1, instead of x, we're going to put 8 plus, and instead of y, we're going to put 5. 8 plus 5 is 13. So our answer to number 1 is 13. In example 2, we're going to replace x with 8 divided by, and instead of z, we have 4. So 8 is divisible by 4, and it goes in there, 4 goes in there 2 times. In example 3, this time you're going to see me start to use substitution parentheses. So I want to replace x and y separately. So x is going to be replaced with 8 and y with 5. 8 times 5 is 40. Then we want to do, I want you to get in the habit of just doing substitution parentheses, especially anytime we follow a subtraction sign, because if y were negative, we'd have to make sure that we did keep, change, change. Fortunately, y is not negative here, but we're still going to use our substitution parentheses. So instead of x, I have 8, and instead of y, I have 5. Fortunately, 8 minus 5 is pretty simple, and that is 3. So those are just some very simple examples. So let's look at the last page. And then these are mostly for you to do on your own. 1, 7, 9, 11, 23, and then 30. You have the answers to all of these in the back of your book. The only one you don't have the answer to is number 30. So try those, check your solutions. If you need help, come talk to me. And then this is going to be your homework for this section.